Hey guys, I'm Samriddhi and you're watching GaugeHow. In the era of high innovations and development, engine performance is a matter of concern for an engine designer. At the design stage, an engineer should design with a certain aim to improve the power output and minimize exhaust emission. To increase the power output of an engine, the amount of fuel to be burned can be increased and bigger explosions can be made in every cycle. To burn more fuel, one way is to increase the size of the engine. But as the engine goes bigger, it will weigh more, building costs will be more, and ultimately maintenance becomes tough. Another way to increase power is by making it more efficient with its regular size. This can be done by introducing more air into the combustion chamber. More air will require more amount of fuel, more explosion will occur, and hence more power will be produced. This method is more feasible and practical, which can be done with the help of mechanical devices known as turbochargers and superchargers. In this video, we are going to learn about the turbocharger. A turbocharger is a turbine-driven, forcefully induced machine which is purposely used for increasing the efficiency and power output of an internal combustion engine. Turbocharger or turbo is powered by a turbine which is driven by waste energy from exhaust gases of the engine. The method of increasing performance of an engine using waste exhaust gases to run the turbine and driving the compressor to intake more air is called turbocharging. There is some confusion which arises between the turbocharger and supercharger. The functioning of the both is same, but the supercharger is driven mechanically by the engine, whereas turbocharger is powered by a turbine driven by the engine's exhaust gases. Turbocharger is assumed to be more efficient than the supercharger as the wasted energy of exhaust gases is used for the power source. Some of the objectives of turbochargers are to improve volumetric efficiency of an engine by increasing intake mass of air, converting the engine's exhaust energy into rotational energy which is used to drive the compressor, transmitting the turbine power to the compressor using a rotating shaft. An intercooler is used for decreasing the temperature of air. A turbocharger has three main components: a turbine, which generally is a radial flow turbine, a compressor, it generally is a centrifugal compressor, and a central or hub rotating housing. Working principle of turbocharger. In a turbocharger, the turbine consists of the turbine housing and the turbine wheel, which has fins or blades mounted on it. Its purpose is to direct the exhaust gases into the turbine. As the engine is operated, hot exhaust gases are passed through the exhaust manifold and fall into the turbine housing, after which it strikes onto the fins of the turbine. The kinetic energy of the exhaust gases gets transformed into the mechanical energy after striking it on turbine blades. The exhaust outlet of turbine housing helps the exhaust gas to come out from the turbine. The compressor is attached to the turbine with the help of a connecting shaft. As the turbine turns, the compressor wheel takes the low pressure and high velocity airstream and converts it into high pressure and low velocity stream. This compressed air is passed through the engine with more amount of fuel and ultimately more power is produced. Afterwards, the air is thrown out by the centrifugal force of the compressor. This causes air to come out from the turbocharger into the engine cylinder. When using a turbocharger, there are some frequently used terminologies such as turbocharger lag, also known as turbocharger transient response time. It is the time taken by the engine to change power output in response to the throttle change. It is a short delay period before the boost. This is basically due to the time taken by turbocharger to accelerate the exhaust gases into the turbine and speeding up the compressor. Pressure increase. It is also known as boost, which means the amount by which inlet manifold pressure exceeds atmospheric pressure. The advantages of turbocharger are: it is lighter than mechanical blower, it involves less moving parts, it can easily deliver large quantity of air, it increases thermal efficiency, it delivers more power as compared to the same sized engine without a turbocharger, it gives better fuel economy, the volumetric efficiency of the fuel is increased, high speed is obtained, and better average is also obtained. Even though a a turbocharger seems to be an all-good thing for an engine, it has some limitations. It increases the weight of the engine. Improper or lack of maintenance can cause frequent turbo lag, and the engine will cost more. The uses of turbochargers are plenty. Some of them are marine application. Recently, 50,000 engines are served by MEN turbochargers worldwide. Industrial applications. Turbochargers are increasing the energy efficiency of industrial plants. Power application. According to surveys, there are approximately 10,000 turbochargers in operation across the world in today's scenario in various power plants. That is all for this video. I hope you like it and found it informative. Thank you for watching.